Good morning, good afternoon, good evening, ladies and gentlemen. And yes, welcome back to the Kev Baker Show with yours truly, Kev Baker, coming to you live from Glasgow, Scotland, right here on Truth Frequency Radio, www.tfrlive.com. It's great to be back again. I hope you're all ready for another information packed show. Don't forget, coming up right after today's show, it's Joe Joseph right here on tfrlive.com with the Freedom Link. Now then, if you're out there listening, maybe you find yourself at a loose end. I don't know, maybe driving. Well, if you're driving, this isn't a good idea. Scrap that idea. But if you're at home, maybe, we've got the chat room that you can go and chill out in. Yes, you can head on over to tfrlive.com/chat. And for absolutely no cost at all, you head on in there and you can add an extra dimension to today's show. We always love to talk about dimensions here, right? And we're going out live, like I say, on Truth Frequency Radio. And that goes out on iHeartRadio, TalkStream Live, and TuneIn Radio apps. And we are simulcasting today as well. So a big shout out to everyone over there at YouTube. And today we've got a really good show lined up. It's one of my personal favourites, because it's topics that I love to get into. Yes, we're blasting off and we're going out into space today. We're exploring some of the mysteries of the cosmos with a guy I like to affectionately call the Black Hole Detective. Yes, indeed, because today I'm joined by Brendan Drachler, and he's an astrophysicist from the Rochester Institute of Technology, working on how to understand how we can better detect the most dense and energetic objects in our universe. And what I'm talking about there, of course, is black holes and neutron stars. Now, he's also working to understand the fundamental structure of black holes and how we can learn more about them. Now, that's going to be really, really key to some of what we go into tonight, folks. So from there, it goes on to say, Brendan has spoken on topics ranging from our solar system to the nature of dark energy to supernova and many other things in between. And on this show, we have gone here, there and everywhere. Yes, Brendan's a very, very clever guy, and he isn't just a one-trick pony. We like to talk about various subjects. And of course, more information about Brendan, and I really, really urge you to do this, is go and check out his website, thestateoftheuniverse.com, because not only is he a really cool astrophysicist, but he's also the host of his very own podcast by that name, The State of the Universe, and you can find that at thestateoftheuniverse.com. He's also really high up on the science rank, or one of the categories over on iTunes anyway. The guy's flying, and he gets the kind of guests that you out there listening to the Kev Baker Show is the kind of thing that would blow your mind. But less from me, and let's go right to Brendan right now. How you doing, Brendan? It's great to have you back, brother.
I'm great, Kev. Your little intro there reminded me when you said that I talk about supernovae, that I have to give a talk about supernovae next Friday, and I should probably get started on that sometime soon. But it's great to be back, Kev. It's fantastic. I love being on the show. I love talking to you. I love talking to your audience. And yeah, let's jump into it. Where do you want to start?
Well, I like that you do the same kind of thing as me. And everyone knows one of my favorite topics is science, dude. It's, you know, and I'm the first to admit, I kind of joke that I'm a pseudoscientist because I'm into some really weird stuff. But I always tell people that it's speculation or theory, stuff like that. But you get on some of the kind of people that literally would blow the minds of the audience. I remember when I first started talking about CERN, for example. Everyone has got an appetite to learn more about that machine over there in Switzerland. And you have some of the people, not only that have worked there, but other particle accelerators from around the world, some of the most famous, right?
Yeah, CERN has probably taken the title of most famous by now, but I'd say for the majority of the history of this field, Fermilab in near Chicago in the United States was probably the most famous particle accelerator. They actually don't collide particles the way CERN does anymore. They've stopped because they just can't do it as well as CERN. They've sort of given up on it. Instead, they study neutrinos now. They study a different kind of particle. But if you want to hear all about that, my most recent guest, maybe my biggest guest ever that I've had on the show, is Dr. Dan Hooper. And he is one of the biggest names in all of the world of particle physics. And he works in particle physics, cosmology, astrophysics, trying to tie all these things together, trying to understand how can we learn not just about dark matter and what dark matter does and how we can detect it experimentally, but what actually fundamentally is it? What is dark energy? What kind of particle is it? What sort of things would have kickstarted the universe? He attacks those problems from the most subatomic way of understanding. And it's fascinating. In fact, your audience will probably like this. He actually appeared on Ancient Aliens too, to talk
Oh.
about Einstein. They did an episode about how Einstein's ideas came to him from aliens, and he was on that episode talking about it.
Now
Of course, what?
you were telling me an interesting kind of fact on how it came about that he ended up on Ancient Aliens, right?
Yeah, so they sent an email. The History Channel sent an email to the people working at Fermilab, and they said, "Hey, we want to drop by and we want to interview you." They didn't give much context. They didn't say like what it's about. They didn't say anything. They just said the History Channel. It's the History Channel. We want to come talk. So they came. They set up shop in like an old warehouse on the facility somewhere in Fermilab, and Dr. Dan Hooper, who I interviewed, was one of the only people. It might actually have been the only person to say, "Yeah, I'll go and do the interview." And he gets there and he realizes the Ancient Aliens people. And he said that they were incredibly nice, incredibly kind, and they just asked him the same question over and over and over and over again. They would ask him the same questions, easy questions, but along the lines of like, how would you describe Einstein? Or how would you describe Einstein's miracle year? Questions like that. And then he would give the response over and over again. And they would say, okay, try to describe it a little differently now. And he's talking about this to me. And he's like, and we talk about this on the podcast, and people can listen to the most recent episode of my show and they can hear him talk about this. And he's saying that after about 4 hours go by, he finally like slips up and he says, it was almost as if you could describe 1905, Einstein's year, as a sort of spontaneous miracle. He says something like that. And then they say, okay, cut. We got what we need. Thanks a lot. And they were very interestingly trying to get him to say something, because of course he wasn't going to come out and say aliens, were the reason Einstein was a genius. Because, is there a chance that's true? Sure, there's a chance that's true. But is that the truth? No, I don't think so. I don't think aliens made Einstein be a genius. So they were just looking for him to slip up, say something, some soundbite that they could use in their show. And then that's the soundbite that they ended up putting in. Astrophysicist Dan Hooper says Einstein's miracle year was mysterious and miraculous. And of course, then they insert the comments about how the mystery could be solved by alien intervention. So it's a fascinating story about how they sort of con you into saying something that you don't necessarily mean to say.
We both do the same kind of thing here, right? Very similar. We reach out to people, and I respect you because you're a good guy. You're just the same as I am. And I imagine that, like me, you would never try and, like, not hoodwink people, but maybe hide some of the information away to get somebody onto your show. I mean, it's best just to be honest up front. It shows respect, right? And this is another difference between one of these big companies and people like us that are doing it for genuine reasons. It's all about the bucks for the History Channel. And don't get me wrong, there's good stuff on there, but they want sound bites that sell. And to hell with the reputation for somebody like you're talking about here. Nobody gives, we never get that context, Brendan, to some of the things that we hear on some of the shows on there.
Yeah, it's an interesting. I mean, the good news is like the community that he is in, since he is arguably at the very top of that community, it's so small. There's so few people at the top that no one actually. He didn't actually ruin credibility in any way. There are people who, though, that like there's a reason the History Channel feels the need to do this. There's a reason the History Channel feels the need to sort of be a little vague about what they're asking you. And the reason is that if they sent an email, the same email, and they said, hey, do you want to come be interviewed because we want you to give us some information about how Einstein was influenced by aliens, everyone is going to say no to that, right? And so it's interesting because the impression I got when speaking to Dan is that he didn't necessarily feel like it was malicious. He felt like it was a fun thing to do, and it was exciting and it was kind of
You
cool.
see,
And
there you
he
go.
doesn't.
If they'd been honest, there's a good chance the dude would have done it anyway.
Yes, that's true because he probably would have done it anyway. Um, but he probably would have been a lot more careful in
Mm.
not saying a soundbite. So it's sneaky, it's kind of weird, and yeah,
I
the
just
History
don't like,
Channel.
yeah, don't like that approach to journalism. Kind of like, it feels kind of
No,
tacky, if you ask me.
yeah,
I don't know.
no, it's
And I
it's
like the
definitely
program.
odd.
I
I
do.
like Ancient
Yeah.
Aliens too. That's the thing. Like it's fun. It's like a fun show. I don't even know how to describe it. It's like a fun show to watch. I had a guy on, Dr. John Hoops. I had him on. He's an archaeologist and he's an expert in the field of pseudo archaeology, like disproving archaeological beliefs. Because there's a ton of, you don't realize it, but like archaeology is one of the sciences where there is rampant pseudoscience. And Ancient Aliens is a huge example of that. And so he spends a lot of his time sort of working with people to debunk a lot of the stuff they say in the show. And he talked about how even he and his colleagues think it's like an entertaining show. It's kind of fun. And if you can weed through the bullshit, if you can get through the nonsense, it's actually a decent show that takes you on a tour of many historical sites. If you can just try to filter out, and I think that's probably what a lot of people do. They get like 2 million viewers a week. I don't think that those 2 million people think that aliens created the pyramids or that aliens influenced Einstein or that aliens were the cause of World War II or whatever other nonsense they push. I think most people just kind of treat it as like an hour of entertainment.
No, absolutely. Absolutely. And, people do want to look into this kind of information. There's a thirst for it. But you brought up the pyramids there. And I must admit, when it comes to like the official story for how they're built, I don't know, dude. Do you go along with that? Or are you open to suggestions that they might have had, not like technology as we know it, but stuff that maybe we wouldn't recognize, maybe stuff we don't appreciate they had back then?
I I This is an excellent question, and I have tried. I don't know if you've tried, but I have tried on multiple occasions to reach out to Egyptologists, people who are an expert on this particular thing, to get them on the show. And so many of them are like just spending their life on archaeological digs and are unable to, sort of participate in something like that, or they just don't want to. I can't get anyone to talk to me about it. I'm ready to put my pseudoscience cap on and think that there's a conspiracy here, because I can't get any of them to talk. But I'm going to continue trying to find someone to talk about it, because I simply don't know.
Yeah, same.
It's like something
Yeah.
I don't know about.
That's why I find it a good topic to explore. And people, I don't know what it is, but there's something about Egypt, ancient Egypt. I don't know if it's in our junk DNA, some ancestral memory. I don't know, dude, but there's something about those pyramids, that place that so many people, I wouldn't call it a calling. That's kind of like new agey type stuff, but it really interests everyone, I find.
No, it's incredibly fascinating. It
Yeah.
interests the hell out of me, because it just feels like there's a mystery. I think that's what it is. It just feels like there's a mystery there that we haven't figured out yet. And I don't know. You ever watch the movie Prometheus?
Yeah, definitely, yeah.
Okay. Do you know the opening scene of that movie where the girl is at a dig site and she like breaks through into this vault and there's like alien artifacts in the
Oh,
vault?
yeah.
I think that scene touches the brain of most people, because that is like the most primal way of solving a mystery. I mean, that's what we're trying to do in science after all, is to solve a mystery, but it's never so clean cut. You never break into a vault and find alien artifacts. I think that most people attach geoglyphs and these large structures like the pyramids to something like that. Like, man, is there hidden tombs? What's going on in there? It's just such an amazingly interesting topic.
No, absolutely. And of course, we're going to be talking about mysteries. And space, the cosmos, it's full of mysteries. And you yourself, Brendan, I mean, this is what you're working on. This is your day job. And I'll get you to tell the listeners briefly about your work with black holes. Now, there's so many stories coming out about black holes in recent times because more and more has been learned about them, because of better technology, better telescopes, better data, more and more people analysing that. And people like you who are working towards, well, let the listeners know what it is you're trying to build a simulation of, because this is going to lead into one of the stories that we're going to get into tonight.
Yeah, we're at an interesting point in the world of astrophysics. We're at a point where our observations are getting incredibly good. The problem, though, with observations is that when you observe, so it takes millions of years for two black holes to coalesce. Okay, and in fact, Kev, we'll talk about this a little bit in a minute about binary black hole systems at the center of galaxies. But it takes so long for that process to happen that in one human lifetime you'll never observe that actual coalescing. Now, there are ways in which we might be able to observe features of it, and those are gravitational wave detectors. But we don't have to go down that rabbit hole. The point is, though, when you're looking at these things with telescopes, the time scales over which they happen is very long. But there's a way around it. The way around it is you do this. You set up a simulation where you know all of the relevant physics. You know how gravity works. You know how radiation works. You know how matter interacts with one another. You know all of the information. You can set it on a supercomputer. You can let it evolve. And you can watch in real time what happens when two black holes coalesce. And then you can start to answer questions like, what kind of light is released in the process? How can we look for these things? What does the gravitational wave signal look like? In other words, what are the parameters by which we can actually detect something like this happening in nature? Okay? And can we find it? Can we then use our telescopes to look for the things that we predict on computers? And so that's what I'm at. That's what I'm doing, Kevin. I'm working in the intersection of all of those fields.
It's absolutely amazing, dude. It really, really is. It's so interesting. And I found a story the other day, and this is what really caught my attention. I knew you were going to be coming back on the show. And the headline here, it says, physicists finally find a way to tell certain black hole types or black holes apart. It turns out nearly extreme black holes do have hair. So I'll ask you, without getting too in depth into this, Brendan, I mean, what different types of black holes do we have?
So first we'll talk about classification of black holes, and then we'll talk about what's meant by hair, because hair is kind of an interesting term that was developed in the 60s and 70s. So there's many different kinds of black holes in terms of masses. Like, what is the mass? There's stellar mass black holes, which are kind of tiny, the mass of a few suns maybe. There's supermassive black holes, which are the things you find at centers of galaxies, which are millions or billions of times the mass of the sun. They can come in all different masses. In fact, there's some masses that we don't tend to find black holes in. It's like that intermediate range, because there's not necessarily natural processes that create black holes of that size. One of the interesting questions, Kev, is actually, how do you create supermassive black holes? Like, how does that happen? I'll send you an interesting article that I didn't, or an interesting picture rather, that happened recently.
Not a good idea to go creating a black hole, I would imagine, Brendan.
No, it's not a great idea to go. So let me send you God, Kev, I'll tell you what, I work with supercomputers all day, yet my ability to use normal computers.
You know what I do? I just blame it on the Skype, my friend. Everyone lets you off with it then because everyone understands.
That's true, actually. Everyone unanimously agrees that Skype is terrible. Unfortunately, there's like no alternative right now.
No.
So I'll send you this link.
Thank you. I've got that.
And so this is a really interesting piece of news that came out recently. And so this helps explain how supermassive black holes are actually formed. Because what was found in this galaxy, NGC 6240, you can scroll down, Kev. So we, oh geez, pop-ups, I hate them. Let's look at that picture quick.
There you go.
So this picture, if you just want to Google search NGC 6240, you can look at a galaxy that is, and for people
NGC
just listening,
6240.
6240. 6240. Yeah. This is a galaxy that we've long looked at and been like, I don't know how to explain this thing. I mean, this is a weird galaxy. It doesn't look like any galaxy any of the listeners have ever seen before. Galaxies tend to come in, and they come in many different classifications, but essentially you have two types of galaxies. Some would say essentially you have three, but essentially you have two. You have spiral ones like the Milky Way that you've seen, which are called spiral galaxies for obvious reasons. They have young stars. They have a lot of star formation. New stars are being created. There's a lot of gas. Then there's elliptical galaxies, which, unlike spiral galaxies, they're not flat, thin things. They're these spherical shells with stars orbiting in a bunch of different directions, and they're really old galaxies, and they're really massive galaxies. But if you scroll up and you look at the top picture, Kev, you can see that this galaxy looks incredibly weird. It looks like we have no idea what's going on here, and we can find galaxies like this all over. And it's long been hypothesized that this is actually the merger. This is the product of a merger of galaxies. Two galaxies coming together and merging, and that's why it looks so crazy. But if you bring up that picture, the inside of the article that I sent you, what's actually happening here through some analysis is that there's actually three supermassive black holes at the center of that giant blob of stars. And this is actually the product of three galaxies coming together and merging at one time. And so that's how supermassive black holes are formed, is you have, pretty massive black holes at the center of each galaxy. All of a sudden you collide them with one another and you get bigger and bigger and bigger black holes. The question, though, of how supermassive black holes begin at all is actually a really open question in astrophysics. Like, how do they begin in the first place, at the center of galaxies? We don't quite understand the answer to that. There's some people who think they do. I think as a field, we don't. We don't quite understand that. That's an open question.
Black holes, it blows my mind, dude. I mean, you've got all of this matter, as I understand it, and it's all in like the tip of a pinpoint, and it's all condensed down there, and then no light's meant to escape it. And I don't know, it's just the weirdest thing to try and imagine. And then again, when you're imagining that, is there anything on the other side of it? What happens to the light that goes into it? All of these things, it's again just the mysteries of the cosmos, man.
Yeah, it's insane. So we can answer that question in a minute, Kev, because I think it's one I've been pondering lately of what happens when something falls into a black hole. We can talk about that in a second, because it truly is kind of an interesting question. And it's something I've been thinking of, and man, it's crazy. The consequences of falling into a black hole are crazy. But so the No-Hair Theorem that you sent me is an interesting one. So for a long time, since sort of black holes were really introduced as a real scientific concept by Stephen Hawking and his collaborators a long time ago, the idea of them having no hair has been a thing. And what that means is there is no observable property that you can look at a black hole and differentiate it from another black hole. So if you look at a black hole and you look at another black hole, there's nothing about those two that will tell you how they were formed or what they were like before they were formed or what's inside of them. There's nothing that can tell you that. So there's no hair. There's no differentiating property. The only thing that black holes have that differentiate them from one another are their mass, their electric charge, and their spin, or their angular momentum. That's it. And those are only properties that we can measure from the outside. So there's nothing that you can measure from the outside that can tell you any fundamental thing about what's going on inside. And so now this research seems to indicate that when black holes are first formed, when their very first formation process happens, then you actually can tell some information about what's happening on the inside. What I don't know, Kev, is how they intend to measure such a process. That is unclear to me. I don't know if they intend to measure the gravitational waves coming from the black holes and try to infer some information from that. Nevertheless, it's interesting research, because if we can start to answer the question of what's going on inside a black hole, that's a super interesting puzzle worth solving.
Now, is this not more almost philosophical at this point because can we really test what's inside the black hole? Let's find out on the other side with Brendan Drachler. Don't go anywhere, folks. Well, that was a very quick segment of radio/YouTube there. Big shout out to everyone on YouTube. Thank you for joining us today. Yes, Brendan, I'm sure people will be looking in the background going, I wonder what that patch is all about.
That's the patch they give me when I'm a NASA shill. They send it to me in the mail. That's my official NASA shill badge.
You're going to send me some NASA coin after the show?
I should send you some NASA gear, actually.
Yeah,
I have some friends that work at various NASA facilities.
I think so. I think so. I could chill for NASA. It would trigger people all over YouTube. It really would. But yeah.
Kev, you should do every show completely NASA'd out.
I think it's
NASA
an idea.
NASA shirt, NASA hat, dress up as a rocket.
Yeah.
NASA shoes.
I need to wear my Google hat. Google would be most unimpressed if I didn't wear my Google hat. Being a Google shill.
That's true. Oh, look, you got the little pyramid there on the side. I didn't even notice that.
Shh. Don't trigger people, dude.
I see your infatuation with the pyramids now, Kev.
You see, when I got that logo, I went to a website called Fiverr, and there's graphic designers and people like that on there. And I said to them, listen, I do a podcast. I was deep into the conspiracies at the time, Brendan. And I said, I want to have a kind of tongue-in-cheek kind of like take on the Illuminati's use of the pyramid. So I explained I was doing a podcast, a radio show at the time, and they came back with that. And I'm like, that is absolutely fantastic. So, and I knew at the time it would trigger people. But then as various conspiracies came to light over the years, it's like, it's doubled its kind of shock value because it looks like other symbols that are out there and it triggers people other ways. It's the logo that keeps on giving.
Yeah, I had my logo created by a college student. I went to a college, I work on a college campus, so I just sort of went to the software development people and was like, hey, anyone want to design a logo for me? I'll pay you. And then I just found some random kid who was willing to do it, and it turned out good. I like it a lot.
And there it is there, of course, yes. The state of... Are you actually standing out in the universe?
Yeah,
that's pretty cool. That's pretty...
Yeah.
You should have put a NASA spacesuit on, really. That would have really triggered people.
That would have been cool, actually. Yeah, I agree.
No, I'm really enjoying this so far. And folks, myself and Brendan, we like to have a laugh with things, but I love to pick Brendan's brain over all things space, all things science. And I urge you all, please check out his website, check out his podcast. You're not going to regret it. And there's a lot of geeks in our audience, and that's no bad thing. I'm a geek myself, and that's how I know. At least check it out, give it a go. And I guarantee, in fact, you'll go back for more. So, Brendan, any good guests in the pipeline for your show coming up?
We have some. I don't like to.
I know.
Speak before, but yeah, no. I've been taking it slow on the guests this past month because I have found myself like making shows for the sake of making shows, and I don't think that's a good way to be. I want to be interested in the conversations I'm having. I don't want to be talking to people I don't want to be talking to. Yeah. Kev, you're probably thinking, God damn it, I'm doing that right now. But
not at all, dude. Not at all. And people on YouTube, you might see this like square up in that corner. That's because the TV's in the background, and I don't want like getting copyright claims because of something appearing there. And it's dead distracting, but sometimes I forget and my head disappears. So yes, indeed. Now we're going to be going back to TFR Live in a moment. Truth Frequency Radio. Remember to share this link. Share TFR Live. You can be in both chat rooms at once. That's how cool it is. Here we go, folks. We're going back now. Welcome back, ladies and gentlemen. Thank you for joining me today. Brendan Drachler is my very special guest, the black hole detective. He's an astrophysicist from Rochester Institute of Technology, and he hosts his own podcast called The State of the Universe. He comes and he is really gracious enough to hang out with me once every month. There's always stuff to be talking about in space. And before the break, we were getting into black holes, and this is precisely the kind of thing that Brendan is working on. And now they've found a way that's going to make it a little easier for them to identify just what type of black hole they're looking at. And now we're going to go into the realms probably more of speculation than hard science. But Brendan's cool that way. He likes to go with me into what I call the woo. And the black hole, we've often spoke on this show, or we've at least aired our opinions on what may lie beneath, if anything, that event horizon. Does it open out into other dimensions? Does it take you out to another place in space like the sci-fi movies would have us believe? Nobody knows. And Brendan himself said he'd been kind of thinking this over, mulling it over in his mind just recently. So what better time to ask him? And then when we're talking about this, I always think to myself, how do we ever test it? Would you be the one to go through the black hole? Think about that, folks. So Brendan, come on, man. What lies on the other side of the black hole?
I think before we address what lies on the other side, Kev,
He's buying himself time.
We should actually address the latter part of your question, which is that how do you ever test it?
Exactly.
And so to ever test it, you first have to understand what happens if you fall into a black hole. Okay, so we should discuss what happens if you fall into a black hole before we discuss what's on the other side of the black hole. Now, this is actually falling into a black hole is not necessarily speculation. Assuming you believe in Einstein's general theory of relativity, which you should, because it's been proven right for about 100 years now, time after time, every time we get a new potential test to prove Einstein wrong, it comes up that he was right after all. It keeps happening. He was wrong about some stuff, don't get me wrong, but his general theory of relativity is pretty sound, pretty foolproof at this point. And it wasn't just because of him. He had a lot of help along the way from a lot of different people, a lot of different mathematicians. If it wasn't for the mathematicians, everything would probably be wrong. Einstein was not the greatest in terms of math. If you ever did general relativity in your life, you'll understand why. It's tough stuff. But, it's interesting. So first we should talk about clocks, because general relativity has a lot to say about clocks, a lot to say about how clocks are weird as hell. Because Kev, we use general relativity in our life every single day when we use a GPS. GPS's global positioning satellites rely on general relativity every single day that you use them. GPS's, the reason they're accurate is because of general relativity. Because what we know is that here on Earth, clocks run slower than they do in orbit. Why is that? Well, the reason is that when you are near a very massive body, the closer you are, the slower your clock will run. That's a weird concept. What does that mean? Well, that means that a second for you on Earth is less than a second for someone in space. Okay?
It's bizarre. Now, it's so bizarre, isn't it?
It's crazily bizarre.
And I get it, dude. I mean, wasn't there the astronaut, the twin that went up there onto the space station, and they proved that basically he had aged differently from his brother on Earth, right?
Yeah, but I don't think I don't think that was due to the time ticking slow. And the reason I say that is because the difference between a clock here and a clock in space is about 38 microseconds per day. So, if you multiply that by 365 days, you still get a very, very low number of seconds. The differences between those two, Scott Kelly and Mark Kelly, maybe was the brother's name. I'm not sure.
Nobody remembers the brother's name.
What was it? I know, that poor guy. He was the one who stayed on Earth. But the differences were physiological more than like age related. The fact that staying in space is probably not good for humans the way that we currently do space travel. We're going to have to do some things differently. We're going to have to do some simulated gravity. We're going to have to do something to mimc our life here on Earth, because there's a lot of problems associated. The fact that your diet is pretty poor, you don't get a lot of nutrients. The whole thing is kind of weird. But those differences were physiological, not necessarily age related. But the point is, though, you're talking about 38 microseconds difference per day between me and the GPS satellite. Now that is really important because GPS satellites have an error, an accuracy, if you will, of about 15 meters. So at any given time, a GPS will be able to accurately predict your position on the Earth within 15 meters. That's pretty good. For most things, that's pretty good for us. We don't necessarily need to use GPSs to be any more accurate than 15 meters. Now, if you did not take into account general relativity, if you did not take into account that a clock runs slower on a GPS satellite, runs faster on a GPS satellite than it does here on Earth, okay? If you did not take into account that fundamental feature, then in about a week, you would be off by tens of meters, hundreds of meters, in fact, and your GPS would be completely useless.
That's going to be a problem, man. That's definitely a problem.
Yes, and so it's very important that we understand general relativity, because if we didn't, then our GPS satellites would be completely useless. And it'd actually be kind of interesting if it was never developed, and then we started putting GPS satellites in orbit, and we were like, man, there's something weird going on here. We don't understand what's happening. We probably would have come to understand general relativity quickly at that point. But, the point is, 38 microseconds per day manifests itself as huge changes in the ability of GPS satellites to predict where you are. So what should you take from that? You should take from that my statement: clocks run slow inside of gravitational wells. Clocks run slow near large objects that have mass. We know that is true by looking at GPS satellites. You know it is true because you use GPS every single day, etc. Done.
So, now, Brendan, just listening to you then, right?
Mm-hmm.
We're stood there, right? Like you and your logo.
Yep.
The cosmos is out just in front of us. And then we kind of take a step forward. And as we go in to the event horizon, right?
Yep.
Wouldn't time then be suspended and almost stand still?
This is the coolest thing. You're onto something, Kev. You're onto something very interesting about the mathematics of general relativity. So imagine that you and I are where I'm standing on my logo. We're at the cusp of a black hole. We're gonna plummet into a black hole, but only one of us is gonna go. Kev, I'll send you. Okay, you'll go into the black
I'm
hole.
I'm up for it, man. I'm up for it. Can't get any crazier than it is down here.
Yeah.
Man.
I'll stand back where I'm at, and you go towards the black hole. You go ever closer and closer and closer. And what I'm going to notice, Kev, imagine we're both on a treadmill or something, and we're both running at the same speed. What I would notice is that you seem to have slowed down. You're not running as fast. You have slowed down as you approach the black hole. But the interesting thing is that if you're looking at me, okay, it would appear as though I have sped up. Because to you, everything's relative. That's where the word relativity comes from in general relativity. So you wouldn't notice that your clock had slowed down at all. You would actually think that everyone else's clock had sped up. I would think that my clock was perfectly fine and that your clock had slowed down. Okay?
It's almost like that effect you can get when you're maybe on some kind of ride at the fair, sitting on the horse going round in circles. If you picture that going fast, if you were to picture one spot, it's almost like you're not moving at one point, right? Because you're staring at one spot. So like you're saying here, when you're in the middle of that black hole and your speed has changed, you actually don't notice it because of your point of reference. It looks like they're moving faster, right?
That's right. Exactly. And so,
I'm just trying to get my own head around it just so I can picture this because it's really,
it's good. It's
really
good.
cool.
You should.
Yeah, it's really easy to get confused as well, man.
It is, but the questions you have are probably questions that everyone else has too. So it's good to sort of be the moderator. That is, after all, your goal, as an interviewer, which you're great at, I should say, Kev. But anyhow, we're both moving ever closer to the black hole, or you're moving ever closer to the black hole. You notice that my clock is beginning to speed up and speed up. Your clock is beginning to slow down and slow down, according to my reference point. And something really interesting happens. What's interesting is that I will never see you actually fall into the black hole. I will never see it because your clock will begin to, as you get closer and closer to the event horizon of the black hole, as you get closer to the point where you're going to actually fall into the black hole, if you will, you're going to slow down to the point where your clock is moving infinitely slow relative to my clock. So to me, it would just look like you were just kind of sitting there, and it would look like you just sort of faded off into nothing. I would stop seeing the photons coming from you. But from my point of reference, you would never actually leave. You'd just be hanging out right at the event horizon. never leaving, just spending the rest of eternity there.
Is this where a
But
thing called frame dragging comes into it?
frame dragging is a
Slightly
a,
different.
a different concept that has to do with space-time itself being very weird near a black hole that's spinning. It's not necessarily important for this conversation,
Cool.
but yeah. But yeah, so I would see you sort of now. Of course, things would happen on your journey into the black hole that we would have to avoid, Kev. Like one of the things is that the gravitational force on your feet, assuming you fell in feet first, the gravitational force on your feet would be so much higher than it would be on your head, and so your body would literally be ripped apart in little shreds. You'd be spaghettified. You'd be sort of ripped. But assuming we can avoid that, assuming that won't happen, and then, another feature is if you actually begin to fall, well, all of the photons falling into the black hole are getting energized so much that they're turning into incredibly infinitely high energy gamma rays, and those gamma rays are going to be bashing off of you and literally, just literally ruining the atoms in your body, ripping them all apart from an atomic standpoint.
Not
So
a good day.
if we could avoid all of that, Kev, if we could avoid the gravity, if we could avoid the ionization, if we can avoid that, and we could just imagine what's happening. So I look at you, you've essentially stopped. You're not moving anymore. But you look back at me, Kevin, what do you think you see?
I think I would see the same.
You wouldn't.
Would you
Remember,
just blur out?
well, remember that your clock, according to me, is going very slow, but my clock, according to you, is going very fast. So you would actually see me go forward in time at an infinite rate of speed. Okay, not speed. Speed's not a rate of time, a rate of ticking clocks.
But
Again,
because
this
you're
stuff,
experiencing it in your slow time, it's just
I'm
gonna
experiencing
it's
it.
just gonna
Yes,
go on and on and on, right?
in my perspective, it will. But in your perspective, an infinite amount of time will pass instantaneously. So as you're falling into the black hole and you're looking back at me,
You're just
you
gone.
will see the entire universe unfold before you. You will see whatever is going to happen in the future of the universe happen in an instant. You will see all of it occur.
Oh,
So
that
whatever's going to happen to the universe, is it going to close on itself? Is it going to just succumb to a heat death? Is nothing going to happen? Is this thing going to go on and on and on forever? Whatever the thing that happens, you will see it instantaneously. That is the craziest thing to
so
imagine.
so could it be then, right? You have that flash instantaneous, Brendan, right? And again,
Hmm.
pseudo world, land of Kev here. The instant after that, immediately you get almost another flash beginning because you pop out into another verse, another world, many
Yeah.
worlds.
So you're talking about actually falling into the black hole.
Yeah. What happens?
Yes.
What happens if there's, dare we say, it's something that lies beneath on the other side?
Yes, and it's not just something, right? I mean, if you look at the solutions to Einstein's equations, which are the equations that satisfy, black holes and all sorts of other crazy features, you can see that there are mathematical models that predict that black holes have two ends. And there are some models that say if you go in a black hole, then there is a connecting, what we'll call white hole, that will put you out at a different spot in time. There's a white hole that could put you off into a different universe. There's a white hole that could put you off at a different point in space. There's all these crazy ideas about what could happen. But unfortunately, that is something we could never, ever test.
It's one of the favorites in all of the sci-fi, and hands up, it's sci-fi, it's fiction. I get it, but of course, it's a convenient kind of way of like opening up the entire cosmos for it being a mode of
Hmm.
travel, And I do. It's one way of thinking about it. What other ways do you think about the black hole, Brendan? When you've been lying in bed, maybe can't sleep. Most people would count sheep. I dare say you imagine black holes, right?
It scares me. It freaks me out. Could you imagine being like, you ever see Interstellar? I actually didn't see Interstellar, but my understanding is that Interstellar did a great job of simulating or modeling what a black hole would actually look like. Or in the one that's coming to mind is in the Star Wars film Solo. They have this scene where they're very near a black hole. That's so terrifying to me. That like boggles my mind with fear. Of course, I don't think that will ever happen. We will never be near enough. I will never be near enough to a black hole to experience that in real life. But it's like, man, it instills so much fear.
So is there no way at all that you can think of, or any reason to create a black hole on a mini scale, like have one in the lab?
I don't think
Because
the prob
most science is reproducible, and I'm not questioning black holes in any
uh-huh.
way, Brendan. You know, I'm there on
Yep.
the black hole. It's mysterious as we know it. I don't need to go any further than that. You know, but could we ever? Would there be ever? Again, we're speculating, dude. But I like the particle accelerators, and of course, they used the language of opening up microscopic black holes and things like that. And I get
Hmm.
it. It's different on the quantum scale than it is out in the cosmos on the macro. But what do you think to that?
The problem with those, with quantum black holes or micro black holes or whatever language you want to use, is that they evaporate almost
Yeah,
instantaneously.
yep, yep.
So you couldn't, and unfortunately, there's no overcoming that effect.
It's like that
They,
zap of time you were talking about, you know, when
yes,
you're in the middle of the black hole.
they succumb to Hawking radiation, and Hawking radiation tells us that black holes can evaporate, and if it's a really tiny black hole, it evaporates incredibly quickly. Um, for massive black holes, they don't evaporate on timescales of the age of the universe, so they will be around likely forever. But small black holes like that, you could never actually sort of study because they evaporate in the instant that they are created. But the concept of black holes is pretty sound science. There's nothing speculative about a black hole. We now actually have an image of a black hole, and we are able to use general relativity to predict every single thing about it exactly correct. How big it should be, what it should look like, what the gas around it should be doing. Black holes went from being. Do you know, Kev? I want you to guess. When do you think the idea of a black hole was first hypothesized? What year?
I would say a good way back, you know, whenever they were able to detect, or should I say, they weren't seeing something that was obviously causing drastic effects. So I'm not
So
one to put a year on it, man. I would say a
okay,
long time ago, like maybe like over 100 years or so.
okay. The answer should surprise you in the audience. The answer is actually, and they weren't called black holes at the time; they were called dark stars. But the answer is actually set the year 1784. Okay, and it was well before we had telescopes powerful enough to even begin to theorize or to even begin to look at regions where black holes exist. I mean, those things were just washed out points of light at the time, galactic centers and things of the sort. We are at the point where we are able to resolve individual stars, in our telescope, and not even resolve. Resolve is not the word. Look at. We had telescopes almost as good as binoculars we have today.
Yeah.
So in 1784, John Mitchell, who is a genius who doesn't get enough credit, was a person who asked the question, what if a star was so massive that it would emit light, but it was so massive that not even the light could escape it, and the light would go up, 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 and then it would just fall back to the surface. And he called them dark stars because he thought that they would be stars that would be emitting light, but then the light would go back to the surface, and you'd never actually be able to see it.
That's insane. That is truly.
Yes.
I mean, I've watched the videos on YouTube, and I think they're kind of cool. Now, I'm not saying they're definitely spot on, but you see our star, and we think our star is amazing, and it is. It's massive. But then you start to compare it to other types of stars out there and other stars that are known, Brendan. And I'm telling you, it makes ours look like a grain of sand. It really does. And now
Yes. If you, yeah.
yeah, I'm trying to
Yeah.
wrap my head around something where the light itself wouldn't escape it. That's just
Yeah.
crazy, man.
Yes. Now we know a star like that wouldn't exist.
Yeah.
But that was the beginning of the seed of thought about black holes. And what's so interesting is that this thought process, John Mitchell very easily, most of your audience could do it after taking some high school physics. Um, Yes. So if you look up a blue supergiant or blue hypergiant star, Kev, it will change your world. Um, but John Mitchell was able to just do some Newtonian physics, some very simple physics, to predict what the radius of such a star should be. And the radius he came to was exactly the same radius that was predicted in the early days of general relativity for black holes. It was incredible. He's an incredible physicist that almost no one knows who he is, but he did a lot. He did a lot in his time. Now these blue supergiant stars, they blow my mind. If you can look at a graphic comparing these to the size of like the sun, I mean, it's just insane. It doesn't even seem real. It doesn't even seem like it's possible. But we observe these. We observe them all of the time.
Whoa.
I mean, and that doesn't even do it justice. There's some great animations that people have made on Reddit and things of the sort that show like infographics of the differences in the sizes. It makes you feel like so minuscule and tiny and
It
meaningless.
makes me think of, I mean, it's even worse than when you see us in the sunbeam, the pale blue dot.
Yes.
It
Yes.
even, I mean, this could be even like, I'm telling you, it's crazy. Again, it's hard for us to wrap our heads around sizes of this nature, Brendan. I've dropped it in the chat room over at tfrlive.com. And yeah, I mean, it's hard to really fathom when you're thinking about something like that, man.
Yes, it like man, I don't even like I can't even when I think about it I like lose my ability to even articulate it because it is so insane. Like it doesn't even seem like it could be real. And we are, I mean, it's fortunate that we don't live around one of those stars. In fact, life could probably never exist around one of
I
those
was going to
stars.
say, I think there might be a problem with life ever taking hold around one of those stars, and I don't need to have an astrophysics degree to work that one
Yeah.
out, right?
Yeah. I
Big
mean, yeah,
time.
you're absolutely. And interestingly, Kevin, it actually has very little to do with, it has very little to do with what you might think it has to do with. So it doesn't have to do with the fact that the star is really big, and it doesn't have to do with the fact that the star is really bright. I mean, those things could feasibly be overcome by just moving the planet further away from the star,
Yep.
right? The problem actually is that those stars don't live very long. They go through their fuel so fast. They just burn through all of their fuel so incredibly quickly that they only survive very, very short lifetimes. I mean, long in
How,
terms of
how,
the age of the universe.
how common is our, I would imagine this basically, you've answered the question here, but does that mean then our type of star is far more common than the likes of this?
I don't know if common. I'm trying to think of population studies. I don't know if common is the word. I think you might be biased in thinking that it's more common.
Oh, not at all. I think I'm so open to the universe being like so much even more than we already know. And that's a
Yeah.
lot, Brendan. So, no,
hmm
yeah. I mean,
No, no, no. I don't mean
in
you in particular.
cosmic
I mean,
terms, I mean, when you think about the billions and trillions of options that we're talking about here, I mean, common,
yeah,
take
yeah. I mean,
your
it's insane.
just a type.
Yeah, if we're gonna find life around a star, it's likely going to be a star like the sun.
Yeah.
We're not gonna find because those stars they exhaust their fuel and they die, and it took us 4 billion years from the beginning of the Earth. It took 4 billion years, over 4 billion years, for us to get to where we're at right now as human beings, and we've only been around for a very short amount of time. I mean, no matter how old you think humans are, even if you hypothesize that humans are 50 million years old, even if you say that, I mean, we've still only been around for such a small fraction of the age of the Earth. And so the only way in which that's possible is if you have a star that lasts for 4 billion years. A lot of stars don't last for 4 billion years. They,
Or Brendan, it could
what?
always be because ancient
Aliens.
aliens.
Yes, exactly. Yep. Yeah. I mean that is a great segue that we can get into after the break about this
I had to
organ
after what we'd been talking about earlier, and I like
yeah.
the show. Don't get me wrong, folks. I like it if I see it's on. There's nothing else on. But for me, I talk about confirmation bias a lot, and I try to like make sure I don't go there sometimes, Brendan. And
Mhm.
when you go into a show that's totally about it's aliens, not even questioning it. Everything you look at eventually becomes you know it was aliens, right? And that's not to criticize them at all, because you people out there know I love that woo. But again, I can still laugh at myself, and I can laugh at that. And yeah, maybe everything we're talking about tonight, just everything. Big Bang's the lot. Ancient aliens. We'll be back after the break. Don't go anywhere. Brendan Drachler is with me. 1 hour down, 1 to go. Ah, Brendan, yes, indeed. So, still live on YouTube. Big shout out to everyone there. And yeah, man, having fun and great information. And again, because we're on Truth Frequency Radio, that's the home of the Kev Baker Show. That really takes precedent when we're on air during the main segments. But for people right now on YouTube, I mean, let's look at some of these stars again, man. This is crazy, right?
Yeah, I want to find this beautiful animation that you can show. I don't do the people on TFR get the video as well, or is that YouTube only?
I encourage people, if they can, to have both open. But I get some people are driving or at work or
right.
And because, you know, TFR, literally that's where they gave me my chance. So I'm always put TFR first, the listening audience. So I try to describe anything that the listeners are seeing. And also I try and drop in the relevant pictures like the one there. I put it in the chat room at TFR as well. So I try as best I can to keep everyone up to speed, Brendan.
Yeah, that's
it's like juggling about 1,000 plates here. That's what it's like. I make it look so cool and that, you know. No, it's dead easy. And I enjoy it. I think this video component adds a lot to the information when you can show stuff as well. But yeah, remember, folks, check out tfrlive.com. Anne Craney has become a new member. You know, Brendan, unbeknown to you, Anne Craney is my other half. Yes, she's become Anne. In the chat room here, you'll see a green thing. So she's become a member of the YouTube channel. So that means Homer Simpson's going to appear on the screen in a moment. And yes, thank you, Anne. She didn't even tell me, folks. Behave in there now. The shoe is in there.
So, Kev, I found this fantastic video that I'll send you.
Awesome.
This is a great one. This one, you can play it when we're back on the air. It will, if it doesn't boggle your mind, then I don't know what will. I mean, it just makes you seem so minuscule. It makes you seem so minute and unimportant to the universe, that you're just on this little cosmic dust, this little piece of dust that means nothing.
We've got about a minute before we go back live, but yes. So how's the show going then, Brendan, for the listeners here before we go back live? Where can people hear it? Because you're more viral than I am online.
Everywhere. YouTube, Stitcher. I've been getting so much traction on Stitcher this month. This is I don't know what happened on Stitcher. I don't know if someone advertised the show. I don't know if we are on like high on the charts there. I don't check every platform. Certain platforms I just don't. I put the show there. People will listen if they want or they don't, whatever. Stitcher, for some reason, we've been like going crazy. So people, if you listen on Stitcher, the show's available there. It's available everywhere. iTunes,
big hello to everyone on Stitcher. If you
YouTube,
re-upload this
everything.
Or whatever, yes. So how's life in university land? Work going well?
Yeah. It's going well. This is the greatest week in all of America. Thanksgiving,
yeah, I'll get your take on that when we go back as well. Yes, indeed.
Amazing.
We've got a super chat coming in here. Now, I've turned off the AI voice, folks, just in case anyone tries to say anything rude or bad and it goes out over TFR. But yeah, we've got the blue star where the Smurfs live. Yeah, that would be where the Smurfs are from, right? Definitely. They would definitely fit in well there.
Yeah.
Are you too young to remember the Smurfs?
No, I know this. My wife actually has a Smurf tattooed on her.
Righto. Yeah. I thought maybe, you know, showing my age now, man. Dang.
No, I think the Smurfs were popular when I was a.
They're probably politically incorrect now. They're probably too blue. They probably offend people who identify as being blue.
Enough. There's yellow.
Here we go.
Have yellow Smurfs.
Here we go, folks. Here we go. Welcome back. Hour number 2 with today's special guest right here on the Kev Baker Show. I've got our good friend, astrophysicist and podcaster, Brendan Drachler. And today we are getting into his forte, you know, black holes, things like that. And I call him the black hole detective because these mysterious things, as we're now finding out, you know, that were starting to be hypothesized and speculated about hundreds of years ago, you know, more and more about them in the news today. And then during the break, we were having a bit of a laugh and a joke, and we've been looking at the size of stars and a blue supergiant star. And somebody talked about how, you know, it could be the perfect planet for the Smurfs. And then I was saying that to Brendan, and I thought, oh dear, maybe I'm showing my age here. But thankfully, Brendan remembers the Smurfs. I can
Yep,
breathe
I
easy
know
again,
Smurfs,
dude.
and they even made those new movies, those new Smurf movies that are not animated. You know what I'm talking about?
Yeah,
They're like
but
weird.
it's not the
It's a
same as the old Smurfs. They're too, I don't
very
know.
weird.
Yeah,
It does not translate to like a
they're like
non-animated.
vegan Smurfs. They're like very vegan soy type
Yeah,
Smurfs.
it's weird, man. You got that pedophile chasing him around all day. It's
Yeah,
very weird.
it's not right. It's definitely not good. No, not at all. So, Brendan, tell people before we launch back into this where they can hear your show and where they can follow you on social media as well, man.
Thestateoftheuniverse.com. It's very simple. Click the links there. You can follow me on Twitter. You can follow the show on Twitter at Brendan Drachler or at TSOTU Pod. All the good names on Twitter were taken for the podcast. I don't know why. I don't even know who owns the damn like handles because they don't use them. So I don't know. Some shark was out there and he saw I was making the show and he got the handles ahead of time. That's going to become a commodity soon, actually, Kev, where people are reserving the handles. It might already be one and then they're selling them to you. Um, Also on Instagram, go there, do all the great stuff. Follow us there. YouTube, iTunes, Apple Podcasts, Stitcher, Spreaker, Spotify, Google Play. An endless number of places they can find the show.
Now, we were talking about the size of stars, and we both have a good working and good friendship kind of relationship with Brian Keating, right? And
Mm-hmm.
he's the famous cosmologist, really, really cool guy. And he talks about the Big Bang. And the last time he was on the show with me, he was talking about the cosmic background or microwave background. And I was reading something recently, and I could find it, but just kind of bullet points. It was talking about the expansion of the universe, or possibly it's slowing down. Now, again, we're going to theorize here because see, when you get to the edge of the universe, I mean, what happens there, Brendan? Are we in a bubble? I mean, is it just infinite? How do we best understand what we're contained within?
Mm. It's an interesting
Big
an
question. I
an
literally,
interesting
yeah.
that's probably a Brian Keating question because that's a hmm I'd have to lay in bed and think about that one, Kev, about all of that because you know there is no necessarily edge to the universe. There's a uniform expansion in all directions. There is no like wave that is propagating out into infinity where the universe is being created. The universe is, as it always was. The space between things is increasing. It's it's crazy. I'll take you down any black hole questions you want, but maybe questions about the formation of the universe Brian Keating can handle.
Oh, so then, right then, let's go back to the black hole then. What about, what about, and I've heard it been said before, possibly, potentially, if you're into the many worlds kind of idea, stuff like that, perhaps this is a point where one verse, or as they sometimes like to show it graphically, a bubble, you know, one bubble touches on another bubble. Any
Yep.
thoughts on that kind of idea for the black hole?
Yeah. You know, there are hypothetical theories out there that say that when you go through a black hole, you could end up in another universe. And there's actually people working on understanding the mathematics about getting into a black hole and if there is a way to enter a black hole such that you don't undergo what you and I just talked about undergoing. If there's a type of black hole that you need to enter, if there's a way in which you can enter it, if you can send information through it, if you can retrieve information from it, all of these questions are trying to be answered by people. Um, and it is a
See, that's the thing. If you could send information through it, I mean, we hear about scientists trying to digitize consciousness, things like that. Big ideas, okay? Big ballpark thing. It's harder than it sounds, obviously. But again, that kind of thing. You start creating wormholes if we someday master that. You send that digital consciousness somewhere. And again, it's not a physical. There's ways we could do this, dude. I love to think about this kind of thing. I'm a
Yeah, but
sci-fi head.
the conundrum is that there's no way to communicate back to us this digital consciousness because all right, so imagine, if you if you go into a black hole and you pop it out into some other place in the universe, you couldn't go back into the place you popped out and come back out of the black hole.
You
That's not
could
how
you
it
could
would
have
work.
watched Stargate. You dial it in.
Yes, of course. There are people that have come up with theories about designing spacecraft that can move at high fractions of the speed of light. But of course, the problem there is that your clocks tick at different speeds. So if someone's cruising along on a spacecraft, their clock is going to tick. Your clock is going to tick way faster than their clock. So they'll get back to the Earth, and you will be long dead. Society might be dead. The Earth might be dead. The sun might be gone, and they'll get back here, and only a few years will have passed for them. So they'll be confused. The conundrums here aren't that we can't travel. I mean, right now we don't have the technology to. But even if we do develop the technology, it doesn't appear like relativity is going to allow us to travel and explore the universe in such a way that we will actually be able to communicate that information with other people in the same generation.
I
That's
think even if we cracked it, I think there'd be an error correcting code in the Matrix. I think like the closer you got to the black hole, like something would go wrong
Yep.
with the ship. There would always be something that goes wrong. You would just
Hmm.
get to the point of doing it, but then something, just something, dang, you know, Brendan left
Yeah.
that spanner out again. You know what I'm saying, Brendan? It's just
Yep.
one of
Yep.
those
Yep. Yep.
rules, a law of physics that we haven't come anywhere close to and we don't want to, but it just ain't allowed to happen. It's a rule.
Yeah. I mean, there's man, the simulation theory. All of it is insane. It just when you watch videos or you think about black holes, for those of us that have been sort of taught to understand them, or if you just watch videos where they're conceptualized to you, it just instills this like overwhelming feeling of solace because you start to realize once you understand relativity that you're essentially stuck here. I mean, you can explore like Mars, maybe, sure, Venus, yeah, why not? But the likelihood of this civilization going interstellar or intergalactic is essentially like infinitesimally small. We're probably going to end up living the rest of our. But I say that, Kev, and I have to preface that with there's physics. Undoubtedly, there's physics out there that we don't know yet, and we will begin to understand. And that is actually the subject of my entire conversation with Dan Hooper. Is my most recent episode with Dan Hooper. He wrote a book and he essentially poses the interesting question: what was it like to live in 1904 before Einstein had come up with the special theory of relativity? There were a lot of loose ends. We knew a lot of information. We had a lot of open questions, but Einstein was the person who was able to tie all of them together with a uniform theory and actually answer them. Dan Hooper poses the same question about today. What if in 2019, dark matter, dark energy, inflation, the inability to unify gravity and quantum mechanics, what if all of these are loose ends? And the way in which we tie them up is by understanding a new physical reality about the universe we live in. There has to be someone or some person or some team or some group that can come to understand something fundamentally new about physics. And maybe that will be the unifying principle that solves the problem of dark matter, the problem of dark energy, the problem of how the universe began, the multiverse theory, quantum mechanics, gravity, the unification of the two, the Higgs boson, all of it. Is there anything that can unify them all? That's the question.
Well, now I'm hitting you cold with this, but it's something I've been
Okay.
keeping my eye on, okay? And this
Mm-hmm.
comes from Universe Today.
Yep.
And it says here, and we'll just get into the bare bones of it, but it says a fifth fundamental force could really exist, but we haven't found it yet. And it says the universe is governed by four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. Now, these forces drive the motion and behavior of everything that we see around us. And at least that's what we think. But over the past several years, there's been an increasing evidence of a fifth fundamental force. New research hasn't discovered this fifth force, but it does show that we still don't fully understand these cosmic forces. And if we come down here, if it just talks about the experiment that they've done, well, basically, what happened was, the paper looks, this fifth force, hang on, we'll start from this point. Then there is dark energy, detailed observations of distant galaxies that the universe is expanding at an ever-increasing rate. There seems to be some kind of energy driving this process, and we don't understand how. It could be that this acceleration is the result of the structure of space and time, a kind of cosmological constant that causes the universe to expand. It could be that this is driven by some new force yet to be discovered. Whatever dark energy is, it makes up more than 2/3 of the universe. Now, it goes on to say that this fifth force would also interact with particles we have observed in subtle ways that contradict the standard model. And that brings us to a new paper claiming to have evidence of such an interaction. Now, it would appear, Brendan, that since I first seen it, they've ruled out that it is a fifth force. But when you're talking there about something we don't understand, are you open to some fifth force being out there that we could be, close to discovering that would help us understand everything better?
Of course. Yes. Yeah, 100%. I mean, the thing is, this fifth force, if they're talking about a force to describe dark energy, which I assume, which based on what you read, they're trying to understand why is it that the universe is expanding and what the hell could be causing it? Because gravity's not causing expansion of the universe. The weak and strong nuclear force aren't doing it. Electromagnetism isn't doing it. What is doing it? And so, yeah, I'm open to the idea of a fifth force, of some fundamental force of nature, something that is strong in the empty vacuum of space, because that's where we see the expansion actually happen between galaxies. Sure, of course.
And Brendan, this was something, it was a team from Hungary, the Academy of Sciences, and they were expecting particles to act one way. It was helium or something else, but they acted out with what they thought they understood. Now, like I say, this article I'm looking at here, this is from the 23rd. This is one of the ones I seen when they first published. And now, obviously, that it's getting peer-reviewed and things, people are picking holes in it. But it does make me really encouraged that they're looking for fifth forces, because, again, we come to this every time. And it's important to say, a lot of people think that scientists are really closed-minded. And it's very, you stick by what's out there right now. But I've come to learn that scientists are just as keen, if not more keen, than people like me and the listeners to get to new stuff, open up new fields of knowledge, right?
Yeah, they're people just like you. There's no grand conspiracy. This book, actually, I don't know if you can. At the Edge of Time.
You've not built a career on four forces. You've got nothing to lose.
No, of course not. Because the thing is, most of the forces we know of, they tend to act in different regimes. Electromagnetism tends to act in a different regime than gravity tends to act, and of course, all of these forces are occurring at one time. But the weak nuclear force, you don't really have to worry about it if you're talking about a planet orbiting around a star. The strong nuclear force, you don't really have to worry about it in that context. Even electromagnetism, you don't even have to worry about. That's a gravitational problem. If you're trying to understand how two charges are going to interact when two electrons come near each other, you don't really have to worry about gravity. Electromagnetism is the important force. And so all of these forces tend to act in a vacuum. And it's very possible that the fifth force is just operating in some area of physics that we just haven't explored yet. And it would not surprise me to learn that there is a fifth force, and that force acts in the region between galaxies, and somehow it is a force that seems to push things apart from one another. It is stronger than the force of gravity, because gravity would like if everything would just come together. But whatever this dark energy is actually expanding the space in between this. It is overcoming whatever force is you know, being caused by gravity. And you know, some people have a contention with the fundamental idea of calling gravity a force. You know, Newton told us gravity was a force, but Einstein told us gravity is something very different than a force. Einstein told us that gravity is merely the way space-time behaves when you put matter near it, when you put matter on top of it. And so, you know, some people would say that if you were to add a new force, it would actually be the fourth force, because gravity would be kicked out of the force category, because it's not fundamentally a force. It's more of a reactionary physics.
Thank
It
you for saying
reacts.
that. Thank you, because I often get accused of not believing in gravity. And that's my own fault, right? But it's what you've just said there. It's because it's just a word. And really, it needs more explanation, you know. And I like how you put it there, dude. That was perfect. I'm going to go back later on and write that all down so I know what to tell people the next time. It's not that I don't believe in gravity. It's just I think there's a lot more going on, as we're talking about here, a fifth force. And I think of dark energy, you know, I think of that as almost like a goo that holds everything together. It's like what everything exists within.
Hmm. Yeah,
Again, it takes
I
us
mean,
no
it. You
closer
know,
to understanding it, but in my mind, it's like it's everywhere. It holds universes, galaxies together. It permeates
yeah.
everything.
People have tried to understand dark energy from the side of general relativity for a long time, because general relativity says that gravity is not some force. It's not the way Newton described it. It is instead that in the universe we have space-time. When you put stuff on top of space-time, when you put matter on top of it, you curve it. That's why things go around that's why there's orbits, because you've fundamentally taken a bowling ball and put it on a bed sheet, and the bed sheet has curved. And you know, that's the way Einstein talks about space-time. That's the way space-time depicts how gravity works. The question is, what happens when nothing is on the sheet? Right? People have tried to attack this problem for a long time. What happens when you take the bowling ball off the sheet? What happens when there's no matter on top of the sheet at all? And this is essentially asking the question, what happens in the region between galaxies, where there's no matter, where there's no mass, where there's very little stuff? What happens then? What does space-time do then? Does it expand? Is that what dark energy is? Is there something we don't understand? Does Einstein's general theory of relativity need to be changed in some fundamental way? All of these questions have been asked for a long time. Now, with that being said, a lot of the alternatives that have been created, and I talked to Dan Hooper a lot about this. In fact, I think your audience would like that interview, because he is in charge of a lot of funding. You know, he sits on, not in charge of, but he sits on many committees and decides what gets funded and what science is worth funding. And we talk about this, like, what science do you choose to fund? And he talks about how it's worthwhile to fund new ideas. You know, how it's good. It's good. If someone thinks that they have an experiment that can prove that there's a fifth force of nature, or that they understand how dark energy works, it is worth giving money to that thing. No one is going to say that that is not a worthwhile pursuit. Now, some people might say it's better if you give me money to study the thing I want to study, and not give money to that other person to study the thing they want to study, because there's not an infinite amount of money in this field. So I think that, as Dan describes it, there's a lot of bread and butter science. There's science that we know we can get results from. There's science that is essentially loose ends, and we know that if we just put manpower on those questions, that they will get solved. And there's also groundbreaking new science, and both things are worth funding, because in the case of the groundbreaking new science, it's possible you don't get an answer. It's possible that your idea was wrong. It's possible your theory was faulty, but you have to spend the money and you have to put in the time to figure that out. And in some cases, that results in you coming up with some groundbreaking new way of looking at the world. That's what happened with LIGO. That's what happened with the gravitational wave detectors. Everyone thought that idea was stupid. Everyone thought that idea wouldn't work. Everyone thought that you could not detect gravitational waves. And then after 20 years of development, LIGO was able to do just that. So we test new ideas every single day in this field, every single day.
I think it's amazing how humans, you know, we can have the ability to dream up these theories, these ideas to begin with, and then further from that, sometimes unfortunately, the people who first imagine or come up with what might be there, they never get to see it all coming to fruition. Maybe hundreds of years may pass, but it's encouraging now, with the technology we've got more and more, faster and faster. We're starting to really gain a better understanding of everything, Brendan, and that's something that we should always be optimistic about, right?
Yeah, of course. There are critics of science. Sean Carroll is actually a big critic of science.
You need to have critics of science, though, because you need to have people that challenge the science.
Exactly.
And as long as it
100%.
stands up to scrutiny,
Yeah.
then that's good science. That's what makes science, right?
Yes. Yeah. But what I mean is there's critics. I don't mean to say there's. Of course, it's good to have people who criticize ideas and theories. That's exactly what science is. But what I mean to say is that there's critics about the speed of science. Okay, because over the last 40 to 60 years, there has not been an overwhelming abundance of paradigm shifts. There has not been groundbreaking ideas that change the fundamental way we look at the universe. And Dan Hooper might say, it's going to come. It's going to come in time. It's going to come soon. And Sean Carroll is someone who has criticized certain fields because of the slowness, the pace at which that new discoveries are being found. And I don't think it's because there's lazy people. I don't think it's because people aren't trying. I think it's because in some cases we do get stuck in trying to tie up loose ends instead of trying to explore new avenues. And unfortunately, Kev, we've talked about this in the show before, but it's tied to money. If you want to go out there and try to study all brand new ideas, it's going to be tough for you to get money. But if you want to go and study ideas that are going to get results because they're kind of low-hanging fruit, they're loose ends that are worth tying up, that's good science, and it's safe science. But it's not going to you're not going to be Einstein by doing that science. And so a lot of people lean towards the side of doing the safe science instead of the risky and groundbreaking science. I mean, you have to understand that getting an academic job in the United States of America and abroad, getting a job where you're a researcher at a university on a tenure track position, that's like the lottery. They're so hard to come by. And so people tend to play it safe, and they tend to just do the science that will get them papers written and will get them like loose ends tied up and get their name on as much stuff as possible. Because the other option is you try to do groundbreaking science, and maybe 1 out of 100 people will. Like they'll actually come up with some fundamentally new way to understand something, but the 99 out of 100 will fail. And in science, unfortunately, we don't reward failures the way we should. We tend to reward successes, not effort. And that's a weird way in which this field has progressed.
So when me and you go to Egypt and we dig up the alien artifacts, that'll be a eureka moment, you think?
Yeah. I might get an archaeological university to hire me.
Big time. Now, Brendan, before we go to the break, let people again know where they can hear your show, because you were talking about one of your guests there, but you've had many guests on. I mean, that was episode number 66 we were talking about, Dr. Dan Hooper. Who else have you had on the show? Who can they find in the archive? Who can they look forward to?
We've had so many people. We had, I was talking about gravitational waves. We've had Nobel Prize winner Ray Weiss on, and he talked about that experiment. He talked about overcoming people's doubt. Exactly what we're talking about right now. He talked about how in the 80s and 90s, no one believed he would succeed. The NSF didn't believe he would succeed. The NSF thought they were giving money to a failed idea, and he ended up proving them wrong 20 years later. I've had him on. I've had Dr. Priyanata Rajan, one of the top cosmologists in the world. So many people. No matter what the topic is you're interested, chances are we've had someone on the show. And if there's a topic you are interested in and you want to hear an expert talk about it, let me know and I'll reach out to someone.
I think when we come back after the break, I'd like to hear about a little. Well, hang on, we'll have a look through the break. Bernie Taylor on there, one of my personal guests we've had on here, a good friend as well. He's an interesting cat, right?
He is, yeah.
Very.
Bernie, I always have to give respect to Bernie because, when you start a show, it's hard to find people that will participate in the show initially. Bernie was one of the first big names that would actually get some traction, and he came on. So always have to show respect to the roots.
Yeah, big time. So yeah, folks, check out thestateoftheuniverse.com, thestateoftheuniverse.com. You can get it at Spreaker, iTunes, everywhere online. Don't forget, coming up after tonight's show, it's the Freedom Link with Joe Joseph right here on TFRlive.com. And of course, the Kev Baker Show. They'll be back tomorrow night. We've got one segment to go here. Back to opening up the phones tomorrow, folks. I'll let you all have a heads up on that one. Yes, tomorrow the phones will be open in the second hour of KBS tomorrow. So I'm handing over the show to all of you. What woo are you going to bring to the table? Where will it go? Well, only you know. And that's all to look forward to tomorrow night. But one more segment with Brendan to go. And he sent me a load of stories today. We'll hit them real hard and fast after the break. Don't go anywhere. Yes, Brendan, usually, you bring all of these topics and I just turn up here. But tonight I've been really picking your brain, man. It's been like Guantanamo Bay.
No, I like it. I'm fine with it, man.
Good stuff, good stuff. So
this is why we're here.
We often talk about, the real world as well, what's going on with current affairs, things like that. What's been catching your attention lately, as we come towards Thanksgiving in the US?
I love Thanksgiving. This is the greatest time. You get football on, all the American football, not, no one cares about soccer. That's unanimously decided.
Well, I'll tell you what, though. The MLS, I mean, again, it's never going to compete with the big hitters, right? But you see some of the crowds there in Atlanta in particular. You've got the Portland Timbers. They really do get good crowds now. So there is an interest in it. And again, I'm the first to say it's never going to be. And I like the American football, dude. I do like it. So, yeah.
Yeah, I love sports so much. But yeah, I love Thanksgiving. You get like 5 days off in a row. You get to celebrate giving common colds to all the Indians and murder. Native Americans.
We don't get Thanksgiving here, dude. All we get is that pesky Black Friday tradition. We don't get all the fun and games. We just get the annual running of the sheeple where people go crazy and break each other's noses over a $5 toaster. We get that bit without the feast.
It's so insane. I'm not a Black Friday kind of guy.
Do what we do, myself, Joe, and Scott Lopez. We analyze the annual running of the sheeple. Yes, we take a look at some of the crazier videos that always emerge this time of year. And I find it's a good way to. It's almost a tonic. It's almost like
you guys should go live on scene.
That'd be cool. Over here in the UK, though, if you were even caught filming that, people would really, because it's like high tensions. I mean, come on, man. Not very often you get that toaster for £5. If you get caught filming that, you might trigger somebody. You know.
That's fine. It's fine. You should just go on scene, live reporting.
Like a wildlife show, just like hide in a bush. Here at the annual running of the sheeple. Yeah, you put the whispered voice on, and I think that'd be pretty cool, like a safari show, man.
It would be fun.
Crazy times. So, Brendan, when we come back after the break, you gave me a couple of stories, right? Europa was one of them. We'll go to Europa. What else can we hit quickly before we leave these great people to go back about their day-to-day?
I think probably Europa and finding sugars in meteorites probably be the most interesting things for the audience.
Here. There's Europa. I've got that one. There it is. Yep. Close the other ones down.
It's fun science.
Yeah, definitely. I must admit, the sugar, that story, that caught my attention when I seen it. Very interesting.
Yeah, what is this live call-in you do?
Well, it's on the show. We have a telephone line at tfrlive.com. And in recent times, I've been opening up the phones. People phone me with, like, paranormal stuff, anything they want to talk about, really. It adds an extra dimension again to the show. And because we've got great listeners, then that's kind of my way of giving the show back to them, because they make the show, Brendan, as you'll know yourself. You know, some of the listeners who do reach out to you and things. I think it's a kind of cool thing to have, right?
Mm-hmm.
Definitely. Yeah. I'm just watching the time here. I'm not distracted. Here we go. Let's go back to the network. Final segment, ladies and gentlemen. Welcome back. Yes, Kev Baker Show right here on TFRlive.com. Don't forget to share it out. Tell everyone about the place where you get protection from deception and where silence is consent. Tonight, we've got our NASA hats on. Yes, indeed. I'm joined by Brendan Drachler, astrophysicist, Rochester Institute of Technology, podcaster, and he's here once a month. And I'm delighted about that. And of course, Brendan, ahead of time, I hope you have a really nice Thanksgiving coming up, sir. Yes, indeed.
Thank you. Appreciate it.
Don't eat too much
love
now.
it.
Yeah, I'll be
I'm
looking.
gonna eat so much. It's the one holiday where America gets to celebrate their fatness.
Awesome.
It's amazing.
Awesome. And like I was kind of sharing with you during the break, I love to watch the Thanksgiving celebrations, and I yearn for the day the feast comes over here. Unfortunately, all we got for Thanksgiving was Black Friday. What is that all about, man? It's like the annual running of the sheeple, as we call it here. So you were saying during the break we should go on location. I don't know. That's dodgy, man. You might trigger somebody.
Well, here's what you have to do for Thanksgiving, Kev. You have to wait until Brexit happens in 10 years.
10? You're optimistic.
Separate from Britain, and then murder all the natives living in your country, and then you too can eat turkey on Thursday in November.
That's a kind of different way of looking at it. Need to kind of think that one over, so I will. But talking about thinking things over, you gave me a couple of links earlier on today. Some of them really, really fascinating stuff. Just the kind of things that I can discuss with you, and you'll give me a really cool take on it. And first up, something that we've talked about on the show before, and that is Europa. Yes, indeed. And we're going to our favourites. Yes, Kev Baker's show, sponsored by NASA. NASA scientists confirm water vapour on Europa. What's happening, Brendan?
Yeah, I mean, this is something that has been hypothesized for a long time. And finally, this year, we were able to, for the first time, actually...
Oh.
People hear that, they always think that you somehow have recorded a video. Unfortunately, astronomy never works that way. Instead, what we do is we know that when water vapor interacts with ultraviolet light, you get a certain kind of emission. Okay, you ionize the water molecules and you get a type of emission, and we're able to record that emission. The group that did this analysis, they looked at Europa for 17 days straight, looking for any interaction between water vapor and ultraviolet light, except for on one day. And on that one day, they found enough interactions to essentially be 2,300 kilograms per second worth of water. That's 5,200 pounds per second of water vapor being spewed out of the moon. That is enough to fill an Olympic-sized swimming pool in order of a minute or two. That's a lot of water. And now this is a really cool result, because it's actually a good thing that they only observed it one night out of all 17 that they looked for it. And the reason that's a good thing is because for a long time, people thought that Europa did not do this sort of procedure where it outgassed. It had cryovolcanism. We see this on other moons in the solar system. If you look up Enceladus, Kev, Enceladus is a really the most neat example of cryovolcanism happening. So it's ENC. Yes, I think you. Yep. So this is a fantastic example of cryovolcanism happening, and you can see in these pictures that there's a lot of cracking in the surface. This is a fake picture, I think, the one you're looking at, but there's some actual real pictures here. You see these cracking in the surface, and we've actually been able to detect these plumes. You can see these plumes spitting out of Enceladus, and they shoot out incredibly fast, 3.4 kilometers per second. That's 7,000 miles per hour. There's these volcanoes on the south side of Enceladus that just spew out water vapor, among other stuff. And finally, we've been able to detect that happening on Europa too. People thought that what you actually were seeing when you saw water vapor on Europa or around Europa is they thought you were seeing sunlight interact with the ice, the water ice on Europa. But now we have a firm detection that that's not what's happening. There might be some of that happening, but what's actually happening is there's actual cryovolcanism. There's little pockets that open up on the surface of Europa and spew water vapor out into the atmosphere. or out into the greater Jupiter orbit. And so this is incredibly fascinating, and should hype up people's interest to go there.
That's what I'm hoping for. And we've spoke about this before, right? As a potential place for a mission. Is there any rumblings that we're going to do that anytime soon?
Yeah, I think NASA is accepting proposals for their next flagship missions. So I think they have 11 proposals right now. And these are giant billion-dollar missions that people are submitting proposals for. And anyone can submit one. Anyone, as long as you're an American citizen, you can submit a proposal for something to do. Now, of course, it has to be.
Racists.
What? I know.
Oh.
These damn people. Yep. Yep. Donald Trump is going to build a wall and keep you out, Kevin.
Oh, imagine keeping me out of the NASA decision-making circles, Brendan. That's them. Yeah. They're doomed. They're doomed.
No. Us here at NASA would never exile you, Kev. You're an integral part of our operations.
I like that. Us here at
NASA.
Do
a lot of our shilling. You convert a lot of our doubters into believers. And if it wasn't for you...
Talking about getting me a jumpsuit, right? I could sit here in my NASA suit, my NASA hat.
Yeah. We get you a spacesuit even.
That'd be cool. A bit warm, I think, dude.
I don't think you'd be able to sit down very comfortably, so you'd have to stand and record, but that's fine.
Be kind of cool. I could slowly bounce about as if there's no gravity and things. Yeah. Kind of cool.
Yeah.
But listen, all joking aside, another cool space story, right? And it kind of links together in my mind, because when you hear about this ejection of stuff coming from planets or moons, in this case with Europa, my mind immediately thinks, well, what else has been spewed out of there? And then we had this story turning up, and it's about sugar detected on a meteorite. What's that all about, man?
Yes, so a meteorite that... this is interesting because it's actually two independent meteorites that we found this in. One of the meteorites was found in Morocco, the other in Australia. And we find these meteorites. We find meteorites all the time. We take them in. First we test them. We make sure they're actually meteorites, because before I was at Rochester Institute of Technology, I was at another university getting my degree, and the main astronomer there was also a geologist. And people would constantly bring him in rocks, being like, I found this rock in my driveway. I swear it wasn't there yesterday, but it was there today. I think it's a meteorite. Will you test it?
Was it like Pinocchio? Was their noses growing every time they came in, man?
Yes, constantly. They just if you find a meteorite, that's big money.
Remember there was like a dude that stole moon rocks from NASA?
Was there a guy? I don't know.
Funnily enough, seen a documentary on the History Channel.
Oh, of course. Well, he stole it to give it to the aliens because the aliens use it as fuel.
They actually set him up. It was a sting. The buyer was like the FBI. The guy ended up doing time for it and stuff like that. Real story, Brendan. Yeah, quite interesting.
Cool. I'll have to look into it. Yeah, we were talking about how the History Channel, and I was saying before the show began that the History Channel should really begin putting money into real history again, because I think that there's a real market for historical dramas that depict what actually happened in history, but depict it in a way almost like a Game of Thrones-y type TV show way.
Well, you know what? I think they've done really well, and I have to give them credit for this, because it's reignited a passion that I had when I was younger, when I was in school, and that's for the Viking people.
And that show's on Netflix. I haven't watched it yet, but it's in my list along with a million other things.
Started, and it's a drama. I get that, but there are historical figures that can be researched as best you can, that come from that. And I think that really is a good way of, like I say, getting somebody an interest in something. I get it. It's a drama. They build stories around factual things. But yeah, I like that kind of thing, Brendan. Definitely.
No, it should be done more. I mean, I don't know if on Netflix you watched the show Narcos.
Oh yeah, absolutely, man. It's
incredible. I would love to see. I think people would be so much more interested in learning about the Civil War in America, or.
But you get it, right? Because you've got your podcast, and you don't just do black holes, as we've seen, even the few guests we've touched on tonight, right? And I do a variety of shows, and I'll touch on archaeology, alternative archaeology as well. And I know for a fact that people do have an interest in that. You can look at the analytics, and me, myself, personally, I love all that kind of stuff. and it gets the
Yeah.
imagination going. And again, it's thoroughly interesting. And like you say, there's definitely a market for it because people want it.
Yeah, I 100%. One of my biggest shows ever was with John Hoops on pseudo archaeology.
There you go.
People love it. They're
Yep.
obsessed.
Yep. And again, I think it's that ancestral DNA within us. But maybe it could be ancient aliens. But could these blocks of sugar support like present day aliens on these meteorites?
No, they couldn't. But
Pesky.
what this shows us something really cool. It was done. I think it was about a decade ago. People were able to show in a laboratory that if you took a chunk of water ice and some other compounds that are commonly found throughout the solar system, and you expose it to ultraviolet light, like the light coming from the sun, that you can actually create organic molecules like ribose. Okay, that's really cool because
Welcome.
now we're able to test meteorites and actually find it in there. Now that this is changing our view of life, at least it's changing my view of life, because a lot of the organic molecules that maybe 30 years ago we thought were incredibly special to humankind and were only created inside of the bodies of animals like us. Now we can find that those things can be synthesized all over the universe and in the solar system. And so it opens up many questions that people have asked for a long time, like, did life originate here or did life get deposited here? And that's an open question.
Or was it ancient aliens? See, we keep coming back to it.
The ancient aliens could have deposited us here.
Phone call will be coming from ancient aliens, dude. They'll be having us on soon, I'm telling you.
It's possible that there's some ancient civilization out there and that they knew their star was going to explode soon or undergo changes soon that would have wiped them out. So they took meteorites, and on each of the meteorites they put inside of them some organic samples, and they shipped them in every direction across the universe, hoping that one of them would just plop down in the right environment, and that could be us.
Isn't that something that maybe we ourselves would do? We've already got seed vaults and things like that, and if we were facing some cataclysm, without going all fear porn on people, but what would the governments, the powers that be, decide to do? How would we ensure that in some way, perhaps we go on? Obviously not here. It's the end of this chapter, and I like that idea, man. And that brings in panspermia. I think that's the term you give to this. I like the idea of it. I can't tell you how likely it is. What do you think to it?
Let's think about that. What do you think the government would do if they knew or anyone would do if they knew that the end was near?
They wouldn't tell us for a start.
You don't think?
What, they would cause panic. They would make sure they were looked after first. And then
Yes,
I'm very cynical, dude. I'm very cynical.
No. I think you're probably right. They probably would make sure that they were looked at. I mean, okay, this is an interesting thing. You can look at the events preceding 9/11 as proof that the government would probably look after itself first, because as soon as they knew that planes were hijacked, and you can discuss all day long about how they knew that, but assuming that they just got intelligence and they didn't. And George Bush didn't set it up. The first thing that they did was evacuate the buildings that were likely targets, like the NSA, like the CIA, like the Pentagon, before they had ever even, notified the general public. And although I'm not an expert on the events preceding 9/11, I'm not sure the general public ever even knew, right?
I'm not sure anyone can be expert on that. Who knows what happened that day?
Exactly.
Right? Exactly.
But what we do know is that this is well documented by many people in the NSA, CIA, Pentagon at the time, that they were told to leave the facilities, told to leave the buildings.
Yep, I've heard that as well, dude. Yeah.
So that they knew that they had intel, or however cynical you want to be, people knew that something bad could happen.
Exactly.
And they looked after themselves first.
Very tactfully put, sir. This is why I like you. Very tactful indeed.
So it shouldn't that shouldn't be a surprise. I mean you do the same thing, right? If you had the information first, you would look after yourself first.
Yeah.
You would look after your family first, and then you would focus on other people.
Exactly.
I don't fault anyone for that.
No.
I think as a government, maybe you should be more altruistic, but
it happened. It is what it is. people, as I say on the show, I provide, or in tonight's case, we provide, and we let people decide. Make your own mind up on that. And I definitely don't think they would tell us if they knew about impending doom, maybe at the last minute. But we done a show recently here. It's funny we got into this because there's been a lot of news of asteroids. Apophis is always is rarely far from the headlines, and rightly so. But it got us talking about end of the world scenarios, and not in a heavy kind of ooga booga run for the bunkers prep kind of way. Not trying to sell any prepping products, nothing like that. But when it comes to these shows on History Channel again, 10 ways the world can end. We've got meteors, probably black holes would be in there. What would be, your kind of favorite? Not, it's hard to word this, Brendan, but like, what's your the most interesting end of the world scenario that you've come across when it comes to these kind of things?
The most okay, I'll think about this like if I was going to write a science fiction.
Yeah, do we bring
movie.
about our own demise, or is it something that we've got no say in?
I think the most interesting to me would be like some meteor impact that covered the sky, that wiped out all technology, covered the atmosphere with a thin layer of dust so the sun really couldn't get in, and then you just have some Mad Max type scenarios happening. That'd be the most interesting, personally. But black hole, like somehow there's a black hole we don't know about in the outer solar system, and it comes in and crazy stuff. We're gonna fall into the black hole. All of that stuff is potentially cool too. I don't discriminate in end of the world scenarios. I like them all.
Yes, we're very inclusive here. We like any kind of whatever end of the world scenario.
Black end of the world scenario.
Yeah, whatever they identify as, we're very inclusive here. I get that. But one thing again, before I let you go, I'm excited. I know you're excited about the James Watt telescope.
James Webb.
Sorry. I'm thinking about, and this is the thing I wanted to ask you right now. It's not.
There might be a James Watt telescope that I don't know
That's
about.
a Scottish scientist. Wait, look, James Watt. Hang on now. Let's see. Here it is. Here
is the Watt named after him?
I think it is James Watt, and he was a Scottish inventor, mechanical engineer, and chemist who improved on Thomas Newcomb's 1712 Newcomen steam engine with his steam engine, which is fundamental to the changes brought about in the Industrial Revolution. I wouldn't be surprised.
I think he's too old for the Watt to be named after him.
There we go. Watt. So listen, I dug myself out of a semi-hole there. Okay, just a semi-hole. But Elon Musk, I love the Musk, right? But
I love him.
People with telescopes, they've been complaining because of his many satellites that he's launching into near-Earth orbit and things. What do you make of the Starlink? We've seen them turning up in videos and things like that now, and astronomers are saying this is going to play or wreak havoc with some of our instruments. What do you make of that, dude?
Yeah, it's already a big problem. I think Elon Musk and SpaceX, and there's other companies doing it too. I think Blue Origin's starting with Amazon. I think that Google is looking into the prospect. There's other companies doing this Starlink sort of satellite communication. It's not good. It's definitely something that should be thought about. It's definitely something that, do you see how bright these objects are?
Yeah.
Did you see the video of them? I think it was taken in Norway.
Yeah, it was. Yeah, and I've seen one. Yeah, it went pretty viral. I mean, are we going to end up with it sounds really weird, but a ring around Earth?
Yeah, that would be terrible, right? I mean, and so I think that they're trying to come up with solutions. One of the solutions that has been talked about is to put telescopes on them, to put little telescopes on them, create interferometers in the sky on the backs of them that can peer out. I think eventually we're just going to have to come to the conclusion, though, that the Earth is probably not the best place for telescopes. There's going to be a time when we get really good at traveling to space, and we're going to have to come to the conclusion that the atmosphere is bad and the location is bad and having it be stationary is bad, and that we should probably just build all of our telescopes in space. Right now, it's really costly and not feasible to build big telescopes in space, but eventually we'll get to a point where I think we'll start building them all in space, or One of the things that's talked about a lot is on the dark side of the moon, because space, space observatories on the moon would not suffer from any of the problems that they suffer from on the Earth. There's no atmosphere to contend with. There's no light pollution to contend with. So it might be a fantastic place.
Yeah, only if the ancient aliens that are still living up there allow us to go to that part of
Yep.
the moon. Because
We'll have to pay them a
yeah.
fee. Yep.
Giorgio with the crazy hair. I love Giorgio. I do. I'd love to get Giorgio on the show one day. I honestly would. And yeah, we all know there's bases on the far side. Come on, man.
Yeah, I think I'm pretty sure China has landed a rover on the far side. And it doesn't seem to have encountered any alien interference yet, but it's still young.
Didn't it come across a mysterious goo? Didn't we bring
Oh
that up on the
yeah,
previous show?
And I don't know whatever happened about that.
You see, this is what happens in the world of the X-Files. You get a headline like that, and then the story disappears. And the Mulder, the inner Mulder and Scully, because I identify as everything, I've got a Mulder and a Scully side, got the wig and everything. But yeah, what happens is the story disappears, Brendan. And because the story's disappeared, then it must have meant that it's like alien goo woo.
Mm-hmm.
There you go.
There doesn't. Oh, there's some new articles about it. Oh man, no. There's not really any new articles about it. I guess the news cycle has changed its mind, or it's aliens.
It could well be aliens. That's been the common theme: aliens and black holes tonight. I'll figure out a really cool title for the show. But Brendan, it's been great. I want to thank you for joining me again as usual. We've got a few minutes left, and then you can give people a chance to go and follow you over on all of the social media, all the places that they can get the show. I know you won't give away anyone who's coming up on the show, but I take it we can look forward to some, dare I say it, names that we would probably recognize if you're as geeky as me.
Yes. Yeah, you'll get some black hole, pulsar, neutron star, quantum computing, quantum mechanics, I got tons of people coming. Historians, archaeologists even. So we got some exciting things.
You know what we should do? We should race each other to get Elon Musk on the show. Now, I'm only saying that because that would motivate us both to get the Musk on the show. If one of the two of us could get Musk, it would make my universe, something else we've been talking about tonight, but I definitely see it in your near future. I'm going all kind of psychic, Kev. I can see it, Brendan, definitely.
I appreciate that, Kev. Yeah, I've actually I mentioned this to you. I don't know if you ever get like this, but I had to slow down with episodes because I was making so many that I was at the point where I was like more interested in getting an episode out than I was in actually talking to someone I cared about listening to. And I don't want to be pumping out episodes for the sake of pumping out episodes.
That's why I can only do shows that I'm personally interested in as well, because first and foremost, I'm an infoholic. Like anyone else that comes to these types of shows, we love to learn new things. I love to hear people. Not all have to agree with things that I believe either, Brendan. Not at all. I like to have my own ideas challenged. But yeah, I couldn't do this if it was just for the sake of doing it. And, as much as I do just now on TFR, I've even started a daily stream during the week, usually 3-4 nights a week. And it's where I look at some of the more ridiculous stuff in the world, the dumbest criminals and stuff like that. We have a bit of a laugh. And I find that actually a good balance because it means I can stay interested in the big topics at night. And then I can also unwind during the day as well before getting right back into something serious at night. So I think you've got to have a passion for this. I think you've got to be interested in the topics you do, or the listeners, they'll soon pick up on that. And I think that's what's bringing a winning recipe to your show.
Yeah, I slowed down, so I'm trying to just get people I care about at this point, and that should translate, and that should be people that other people care about too. No filler episodes or any of that. So, no, it's going well, Kevin. I'll shoot for the stars. I'll shoot for the Starlink and try to get Elon on.
You shoot for the Starlink, and I'll shoot for Musk Base Alpha up on Mars. Okay, see, I'm going big, dude. I'm going big. Now, thank you so much, brother. Again, all the best until next time we speak. Please, please, please be responsible on Black Friday. I don't want you going out there and breaking people's fingers or stampeding the masses trying to get that toaster. Or, that TV that you just need to have,
I
Brendan.
do need a VCR DVD combo. I do need one of them. So
do VCRs still exist?
No, they don't, unfortunately.
I was going to say,
that's a lost art, man.
That's like a flux capacitor you need first to get back in time. Go get one of them. Get one of the old Betamax players.
Yes, I remember fondly going to the movie store and renting VHSs of old wrestling matches. That's what I would always do.
Yeah, Blockbusters. I used to like that myself. The good old days. Folks, stay tuned right here on TFRlive.com. Wherever you are, make it TFR. Remember to check out Brendan's website, thestateoftheuniverse.com. And until next time, wherever you are, make it TFR and didn't touch that dial. We're out of here, folks. There we go. And to everyone on YouTube, thank you so much for tuning in today. Remember to check out Brendan's website. I'll be back tomorrow during the afternoon, the morning, the early evening in the UK. I don't know where you all are. I'll be back on the Safe Space, the Kev Baker Show Live. Call it what you will. We'll be taking a look at some of the stuff going on in the world. And I'll be chilling out with all of you in the chat room as well. Big shout out to all of the new members. I can literally love somebody long time tonight that came onto the membership list, since it is my Mrs. Anne who's sitting not a couple of meters behind me. So yes, keep your fingers crossed, folks. If she's becoming a member of the channel, maybe Kev get lucky tonight. Brendan, thank you so much. Before I get hit with a shoe, I'm going to get out of here, right? But nah, seriously, dude, thanks for everything. Thanks for coming on once a month. I really enjoy talking to you, and you definitely give everyone out there something to think about, man.
Well, I appreciate you having me, Kevin. We'll do it again sometime.
Awesome, folks. We are out of here. I'll be back tomorrow.